All right, we're doing area of a triangle today. And you're probably thinking, oh, finally, something that I can do. 1/2 base times height divided by 2. Wrong. That's 7th grade. We're leaving that stuff behind. And it's 7th grade because you needed a right angle present in order to use this formula. Because height is always formed by a right angle. So we need a more powerful formula that's going to work in any triangle. And here you have it. 1/2 side, side, sine of included angle. Included angle. Oh yeah, we are back to geometry. And we are back to side, angle, side. No, we're not doing Proust, but that is an included angle. You see, an included angle is in between two sides. So let's say this side was 5, and then I had this side 6. The included angle would be in between those two angles, x. Thus we have side, angle, side. So that's the key to doing this formula. Make sure that the angle you use is in between your two sides. Find the area of an isosceles triangle whose base angle is 50 and leg is 10 centimeters. Round your answer to the nearest tenth. Alright, so as I read through this, I got to pick out some key words here. Here's my triangle. I want to find the area. So there's my area formula. Isosceles triangle means two sides are the same. Base angle is 50. Oh, right there I can stop and I can look at this. Okay, my base angle is 50. I know another base angle is going to be 50. If two angles are the same measure, then the sides opposite them are equal. So this is 10. If I'm going... Get him, Fenway! Get him, Fenway! Okay, now that you've been entertained. If I start working my formula, 1/2, well, my side is 10. Another side is 10, but included angle, I need the angle that's in between these two sides. I need this angle right here. Well, that's easy to do. 100, this must be 80. Oh, they tried to throw me a little curveball, but I outsmatted them, and I figured it out. All right, now the rest is just, okay, half of 100 is 50. 50 times the sine of 80. Well, this is just calculator work. So what is 50 times the sine of 80? 49. And I can narrow my answer to the nearest tenth, so it's 49.2. So the area of this triangle was 49.2. Next problem. The adjacent sides of a parallelogram measure 12 and 15. Okay, there's my picture. The measure of one angle of the parallelogram is 135. Okay, doesn't matter where I put it, but there it is. Find the area of the parallelogram. Well, I don't know the formula for an area of a parallelogram. All I know is for the area of a triangle. Ah, but in this case, I have two triangles. I have one here, and I have the same exact triangle right here. This side's 15, this side's 15, this side's 12, and this is 135, because in a parallelogram, opposite angles as well as opposite sides are congruent. So really, all I have to do here is I have two area of a triangles. 1/2, side is 12, the other side is 15, and the angle in between them is 135. I have a feeling we're going to be entertained all night by Fenway barking. Half of 2 cancels out, so now I can run all this right into my calculator. 12 times 15 times the sine of 135, 127. Now notice it didn't tell me where to round to, so as of right now I can say My area is, well, let's just say 127 and round it to the nearest whole. Our last problem. A little different. Don't fast forward this. Find the area of triangle DEF. If EF equals 9, DE equals 14, and DF equals 12. Round your answer to the nearest whole. Okay. Seems pretty easy. The area of my triangle is 1/2 side times sine of included angle. I don't have an angle. Well, there's two ways I could do this. I could find the angle. I could find the angle across from the largest side by doing my law of cosines, and then use that angle in my formula. But better yet, I'm going to show you yet another formula. It's called Heron's formula. The capital letter S here means semi-perimeter. So that just means take half the perimeter. And I take the square root of the semi-perimeter times the semi-perimeter minus one side, the semi-perimeter minus another side, and the semi-perimeter minus the third side. So this is a special formula to use when we have a side, side, side. Okay, so the semi-perimeter, well, the perimeter is 14 plus 12 plus 9. So that's 26, 35. So my semi-perimeter is 17.5. Here we go. Semi-perimeter of 17.5 times 17.5 minus one side, 17.5 minus the second side, and 17.5 minus the third side. Let's see, that's 17.5. 17.5 minus 9 is 8.5. 17.5 minus 12 is 5.5. And 17.5 minus 14 is 3.5. Now all I have to do is multiply that all together on a calculator and take its square root. So 17.5 times 8.5 times 5.5 times 3.5 equals, now I'm going to take the square root of that. So my area right here, and I can round it to the nearest whole, is 54 square units if we want to get really particular, because area is always in square units. Done.